So that's this addition. Let's have a look at subtraction. So basic subtraction, we know is x equals a minus b, with a is the manuand, b is the subtrahend, and x is the difference. So it will require a borrow bit if a minus b if a is less than b. So I'm thinking about a decimal example, like if you want to subtract 9 from 10. So the last bit is 0 for the 10, decimal 10. So you have to carry one bit from the you have to borrow one bit from the next bit. So this is the same for binary subtraction. So if this bit a is less than b, you have to borrow one bit from the next bit. Okay. There is another form for the subtraction, which is 2's complement, and it's coming up in the next few slides. It's a very efficient way of doing subtraction. And in fact, that is why this 2's complement data type is or format is defined, because when we have this 2's complement, we can do subtraction using simple adder. So you will say what I mean very soon. Okay, so let's have a look at these subtraction rules. We have this borrow bit in, borrow in. 0 minus 0, obviously is 0, 0. So borrow bit is 0, difference is 0. And 1 minus 0 with 0 borrow in is result is 1. So borrow bit is 0. 1 minus 1 is also simple. It's going to be 0. Difference is 0. So the last row here, we have 0 minus 1. So this is 1, 0 minus 1 actually. This borrowing bit is borrowed from the next bit. So when we are actually borrowing it, we are borrowing this one bit and the different, oh, actually this one should be 0. So yeah, this one should be 0 actually. So let me correct that. Oh, maybe this is okay. So this needs to be 0. Okay, this needs to be 0. Okay, so my drawing is very messy now. So let's so let me just try to correct this later. So again, let's have a look at this last line. Okay, so this 0 minus 1, it's not enough. So we know that 0 minus 1, we definitely need to borrow it somewhere. So that's from next bit. So this one is borrowed to become 2 for the next bit. 2 for the next, because it's borrowed. So it's borrowed, then it will be 0. Probably this doesn't mean that. Okay, you probably just show us that this bit is the bit borrowed. It's not this result of the 2-bit value. Okay, so if that's the case, it depends on how we interpret it. This can be right, but again, this should be 0, which I have corrected. If you downloaded some slides like some while ago, it shows it's 1, which is incorrect. So it doesn't mean to be 1 here to indicate this borrow bit. So 0 minus 1, the result, the difference is 1. That is after we borrowed 1 bit from the next bit. So that is subtraction rules. Okay, so let's have a look at more complex examples. So for this first example, 1110 minus 1001. Okay, so there is a 0 bit, this last bit is 0 here. Minus 1 is not enough. So we have to borrow 1 from the next bit. So from this bit. This bit will be borrowed, and then it will become 10 on the last bit. So 10 on the last bit. So it's equivalent to if we want to we want to subtract 10 from 9. We want to subtract 9 from 8, then we have to borrow 1 from the next bit in the decimal. So this is 10, 10. So what is the decimal value of this 10? So for the binary value, it is 2. It is 2. So in your mind, you know that is 2. That is 2. So that actually is easy if you can just convert its 10 into 2 in your mind to do the decimal subtraction. So 2 minus 1 is 1. So we have 1 here. And that bit is borrowed over. So that bit now is 0. So 0, 0 falls down here. And 1 minus 0 is 1. This is simple. 1 minus 1 is 0. So this answer is 0, 1, 0, 1. So this is the 1 bit borrow. And we have another example of ripple borrow ripples. So let's have a look at this. Again, 0 minus 1, not enough, borrow 1 bit, but there is no bit for from the next bit. So what do? We just go all the way through to the most significant bit. There is a 1, there's 1, and that one has a huge weight there. So that's why we can just borrow it through. So how to do that? If we turn this one, so we borrow 1 from this one, there will be a ripple borrow. So this one will be rippled to the last bit, and we end up with 111 here. So this one borrowed 1, and then this 0 becomes 1. It will borrow another 1 to the next bit. So this is what causes this ripple borrowing. So is equivalent to if I say I want you to minus 1 from 1,000. So the last bit is 0. 1,000 is 1 in decimal, okay? Is that decimal? So 1,000. There is no nothing on the digital. So on the last bit of decimal. So if you minus 1 there, you end up with 999. So that is the ripple borrow in decimal. Ripple borrow. If you have 10,000 minus 1, you have 9999. So that is ripple borrow. It's the same thing here. You have the ripple borrow. So the ripple borrow, the last bit become 10. That is 2. That is 2 in decimal. Minus 1, you have 1 left. Okay, so this, and for the rest bit, 1 minus 0 is 1. 1 minus 1 is 0. 1, this 2 bit just falls down here because there's nothing to subtract. So this is the result we have. So ripple borrow, this is similar to ripple carry. Okay, so it's a ripple. Okay, so that is subtraction